Hello all. Just now we have finished the various Simulink library blocks. Now we will start with implementing some moderate logics using that Simulink blocks. Okay, so let's get started with some basic examples like which everyone frequently learn in their academics digital electronics subject. In that subject, that most of the peoples know about the up counters and down counter using flip flops and all these things they have derived there. So we will learn how can we design the up counter, down counter with this. So first we will see what is up counter. An up counter is a simple counter circuit which counts upward when clock pulses are given. The counter increments the binary number each time a pulse is detected. So that's the up counter which is continuously going up according to the pulses are given to that. Okay. So what is a down counter? In contrast of up counter, the down counter is a counter circuit that counts in a descending order. It will be coming from up to down instead of going from down to up. It will come from down up to down. Okay, descending order. It's decrement the binary number each time at a pulse is detected. So in that way, up and down counter will work. So with the various applications also for up and down counter, we will perform like microprocessor. In a microprocessor, up down counter are used for programming execution, where they act as a program counter, incrementing or decrementing to keep track of the address of the instruction to be executed in the next. Okay, so one is application is microprocessor, another one is timer, frequency divider, and digital clock. So in a timer, up down counter can be utilized to create a digital timer which can count upward stopwatch or downward countdown timer. Okay, in that way. And in frequency divider, by adding a certain circuit components, and up down counter can be made to function as a frequency divider, where the output frequency is a division of the input frequency. And it's used in digital clocks as well, where digital clocks use up down counter to keep a track of time, counting up to 60 seconds and then resetting to the zero. For this purpose also we can use up down counter. So let's get study about the up counter first. Okay, so here I'll be designing here 5-step up counter. So how it will work? 5-step up counter, initially it will start with 0, then it will go to 1, then it will go to 3, then it will go to 4, then it will go to 5, then it will go to 5. Once it will be 5 is detected, then again it will come to 0, then again it will start from 1, 2, 3, 4, 5, 6. So this is a 5-step counter. If I want to design that infinite loop up counter, so that is also possible. I'll just design in front of you now itself. Okay, so if I'll be having this much blocks, that's also fine for me. I'll be taking copy of this. I'll be writing this. Okay, and I am directly connecting this adder to here. And I'll take one more scope here. I'll connect with this. So this makes me the like up counter. Like it will not having like 5-step up counter. It is continuous up counter. It will count until that stop time. It will start from start time and it will stop at start time. Okay, so this is a basic example, and how it will count and how it will work I'll tell you. So in a first step I'll be having input 1 at sample time. First at 0 sample there, this delay doesn't have anything. Okay, but this is having 1 and this 1 should be come here and it's came here. Okay, but at second sample time this 1 came here and this 1 came here, that 1 plus 1 become a 2, then output should be 2 here on a scope, and again unit delay block holding a 2. And next sample time it will, that 2 will go up and this 1 will come there, and again it will come to here 3 as an output. So we will see how it will work and all this thing, no problem. I'll just run this first, this graph, so you can see this is my infinite loop up counter or like finite loop up counter. You can see here the steps. The steps are very small: 1, 2, 3, 4, 5, 6, 7, 8, 9. In that way, it is going. If I want to see this thing in like some step forward in that way, so I'll come here. I'll make this graph. I'll open this graph, and we will run this one step up. So you can see here, here at 0. Okay, if you are able to see at 0, we can see here at 0. Here I have one step now. Okay, if I am coming to the next step, you can see one more step is covered. So in that way, that steps are increasing. You can see now. So this is my stepwise up counter. So I'll run it that completely. So it will count till here. Okay. So in that way, that up counter is designed. This is an up counter. But what what is doing my this logic? My this logic is doing 5-step up counter, and how it will be working that 5-step up counter. So I'll be having input as an 1 here. Okay, and this is my switch case, where my switch case is detecting that number is greater than 5 or not. If the number is greater than 5, then my switch will become a true and I'll get output to the 0. If it's false, then that whatever input is there that I am passing through as a false condition here. And that same delay block holding a previous value and adding continuously. In that way, it will also work. So I'll open in front of you this scope as well. Okay. And we will run one step ahead. Okay. Here also you can see one step up, 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 0, 1, 2, 3, 4, 5. In that way it will work. Okay. So everyone will get some basic doubt here. Sir, this is started instead of 0, it is started from 1. So for that reducing this, I'll connect one more delay here. First we will, I have to run this completely. Continue and finish. Okay. So now this simulation is finished. I'll take one more unit delay here. At the input here. Okay. Now my counter will start from 0. So you can see if I'm opening the scope, again I am making to start with. Now you can see instead of previously it is starting with 1, now it is started from 0. So in that way, my 5-step up counter will work. Okay. Here I will be doing step forward operations. Instead of doing the step forward operation, I can run in a one single shot. But you will not get the idea how it is getting a stepwise counting. To instead of using this stepwise operation, there is one more thing in a simulation. There is simulation pacing option, which is slow down the simulation speed. We will learn that that simulation pacing option also. First, I think now everyone understand about the up counter. Up counter is counting in upper direction. Okay. And this is a 5-step up counter. It will count till 5 step, then again it will come to 0, and again it will start from where it have started. Okay, in that way it will work. According to our application, we can design according to our customer requirement, we can design the counters. So this is my down counter. If I want to take that finite loop down counter, like some how I have created that counter, create in front of you that this also down counter. How can I create that infinite loop of down counter in that way? If I'm saying that, that's so fine. Okay, giving constant as an 100 here, again connecting this to here, and this I will connect with one scope. Okay, so this is my counter starting with 100 and it is getting down, 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 down. In that way it have to work. I think so. We will see. Is that work in that way? Oh, it is going some in another way. I'll start with some one only here, then we will see what will happen. So now you can see it is starting with 0 and it is going down, 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 down till 100. Okay. every one step will be here like 0.1 step. So how you are deciding this step and all this thing? So for your kind information, you can see in a configuration parameter setting, we have already discussed about the solver setting and all. So here I am using a fixed step solver, discrete continuous state, and my fixed step size was 0.1. That's why I'll be getting 0.1 step size. If I am making this to the 1, then what will happen? It will take only 5 steps. Okay, I'll show you here as well. Now, after changing that, if I am running now, you can see you will get easily that only 10 steps. And this thing is applied to the up counter as well now. Okay, if you want to see here, only 2 5-step up counter you are able to see here. Okay, and this up counter is also having only till 10 steps. Okay, because my start time is 0, stop time is 10, and my step size is 1. So how many steps it will cover? 0 to 1 step, 1 to 2 second step, 2 to 3 third step. In that way it will cover 10 steps. Okay, so we already learned about that solver setting, decreasing the step size, increasing the accuracy of our model. Okay, that's the important thing. So that's why I am taking here step size as 0.1. So where I will be getting much more graphs and able to understand. Or else no, I can take 0.001 also, but we are not able to see in a graphs and all this thing. That's why. So we have just learned about this is our like a one down counter which will count till down. But if I want to implement 5-step down counter, so how can I implement? So in this logic, you can see here I have implemented a 5-step down counter. So how it will work? First, it will start. Okay, how it will start? First, it will start with 1, then it will go till down. You can see in this graph it is starting with 5. It is okay. First it is starting with 5 and it is going till 0. Again it is coming to 5, then again it will be going to 0. Okay, after the changing step size, I haven't run the simulation, that's why we are not able to see that much graph. So now here you can see I'll be having so many here. It is starting with 0, 1, 2, 3, 4, 9. In that way, it will 4, 5, 4, 3, 2, 1, 0. Again coming to 5, 4, 3, 2, 1, 0. In that way, it is coming down. So how it is working and all this thing. So initially, I have an input as an 1, and this is a minus 1. And minus 1 is not greater than or equal to 0. Okay, so that switch will become false and it will pass the 5, and then my unit delay block holds of 5 here. Then when it will come here plus 5, okay, minus 1, what will happen? The output will become a 4. Now what the 4, that 4 is greater than or equal to 0, then 4 will be the my output. At that time my switch will become a true. If you want to see that outputs in a display, I'll show you in a stepwise in a displays as well what is going to happen after every step. Okay, so this thing will help you in a debugging process as well. If you are getting some failures, or if you want to know what's the thing like going to be there and all this thing, so it will be very helpful for you. Okay, if you want to see the output of this also, I'll connect one more here. Okay, and now instead of running directly in a one step, I will run in front of you step forward. So at what going to happen in a first step for this? Okay, for the first step for this, how it will work, according to me, first it will go with the 5 in that minus 1 and is less than equal to 0. It's not greater than or equal to 0. So what will happen in that scenario? It will take false and it will show us the output as an 5. Okay, so I have run one step forward, so you can see what I have told you. This input minus become a minus 1, and minus 1 is that switch case is becoming a false, and I'll be getting 5 here, and still that output is not passed to the delay block. In the next step it is passed to the delay block. Okay, now you can see when it is passed to the delay block, this plus 5 minus 1 become a 4, and 4 is greater than equal to 0. So this is going to happen again and again in that way. So if next step I'll get 3, 4, 5, then 1, then 0, then once I'll be get a 0 here, and again it will be -1, the same scenario, then again it will jump to the +5. In that way it will work. You can see in this graph that same thing is happening here as well, and displays as well. If you want to see, you can see the changes in displays and in the graph as well. In that way it will work. Okay, so I'll run and continue forward. So this is all about the down counter. Okay, so if I want to know more about the up down counter, at the conclusion, in the conclusion of up down counter are fundamental elements of digital circuits handling various counting operations in a wide range of digital system. Whether it's keeping track of whether it's keeping a track of instruction in a microprocessor, or making a time in a digital clock, or serving as a frequency divider, the functionality of this counter is very important in everywhere. Okay, so despite of a certain limitation, the practical applications of up down counter in the digital world are vast and continues to grow with the advancement of in this technology. Okay, so this is a very useful technology, up down counter, which industry is continuously growing and using in various applications. Okay, so this is all about the up down counter.